This video is about elimination of arbitrary constants, a useful method in obtaining a differential equation. So one major rule for us to be able to arrive at a differential equation is, we should differentiate the given solution or the given equation or relation as many times depending on the number of arbitrary constants present in the equation. And after that, if in the resulting equation has, or you can see arbitrary constants, then that's the time that you are going to manipulate or to work on the resulting equation and utilize the other equations to determine or to eliminate the arbitrary constants. Now let's have some examples. So we have this given solution wherein you can see three arbitrary constants here, C sub 1, C sub 2, and C sub 3. Ibig sabihin, if you are to obtain its differential equation, you need to differentiate this equation 3 times. The differential equation of this solution is a third order DE. We'll differentiate this 3 times. So differentiating this for the first time, we have y prime equals 2c sub 1 times x. Bakit naging 2c sub 1 times x? Because the derivative of x squared is 2x. And for the second term, we have c sub 2x. If you are to differentiate this, you copy c sub 2 and differentiate x, so times 1. And the last term here is c sub 3. So if you differentiate this, that's 0 kasi constant. Now, you still have to differentiate this. 2 differentiations pa yung gagawin mo dito. So the derivative of this equation will be y prime becomes y double prime. This term here, you copy 2c sub 1. And then differentiate mo yung x, so times 1 ka dito. And then the last term will be derivative of c sub 2 is 0. And finally, you have y triple prime after differentiating y double prime, and then differentiate the right-hand side kung saan constant, so the result of that is 0. So as you can see, this resulting equation does not contain arbitrary constants. It means that this is now your final answer. But this is not always the case that once you have undergone differentiations, you will no longer see arbitrary constants in the final answer. Hindi laging nangyayari yung ganun na case. So we have examples to show you that how you can be able to eliminate the arbitrary constants if after you have undergone differentiation, still you can see arbitrary constants in the resulting equation. Okay, so the first one here is obtain the differential equation of this given solution y equals a times cosine of x plus b. Take notice of the arbitrary constants here. So you have a and b. It means that for me to be able to arrive at its differential equation, I must differentiate this twice or 2 times. It doesn't necessarily result to after differentiation, tanggal na kaagad yung arbitrary constant. So, hindi ganun lagi yung case. So, pag nangyari na meron pang arbitrary constants, you must do something about the equation. You can utilize the previous equations for you to arrive at its differential equation free from arbitrary constants. Differentiating this one, so the left-hand side is y, so the derivative of that is y prime. And on the right-hand side, you have a cosine of x plus b, so the derivative of cosine is negative sign, right? So you copy a, and then negative sign of x plus b. X plus b is the argument of this trigo function, and you differentiate x plus b, and that is times 1. Okay. Now, so we have to differentiate again because of the fact that this equation contains 2 arbitrary constants. Now, the derivative of this will be, so you copy negative a, derivative of sine is positive cosine, and then, cosine of x plus b, and then differentiate x plus b, and that is times 1 because of our independent variable is x. Now, as you can see, the resulting equation still contains arbitrary constants. So you have to eliminate the arbitrary constants. So as you notice, the given equation here, y is equal to a cosine of x plus b. Ayan, nakita nyo dito sa ating final equation that you can see a cosine of x plus b but of different sign. So what you will do is, of course, you utilize this first equation. You substitute na yung a times cosine of x plus b is equal to y. Therefore, by doing that, we're able to eliminate the arbitrary constant. So we have y double prime equals negative y, or you can transpose negative y to the left-hand side. So you have y double prime plus y equals 0. Okay, so this is now the differential equation for this given equation. Okay, now let's proceed to this example. So we have a given solution or equation y equals c sub 1 e raised to x plus c sub 2 e raised to negative x. So yung unang gagawin mo is you count the number of arbitrary constants present in the equation. So there are two arbitrary constants. We have c sub 1 and c sub 2. It means that for you to be able to obtain its differential equation, you must differentiate this given equation 2 times. So we have the first derivative of this equation is y prime equals, again, recall how to differentiate an exponential function. So c sub 1 e raised to x, and then differentiate x in power ng exponential function. So that is 1. And then for the second term, you have yung c sub 2, you just copy c sub 2. And then differentiate e raised to negative x, and that is you copy e raised to negative x and differentiate negative x, which is equal to negative 1. So that's why you have minus c sub 2 e raised to negative x. And finally, for the second time, so you are to differentiate this equation. So that this becomes y double prime equals c sub 1 e raised to x. Okay, c sub 2 e raised to negative x. Differentiate negative x, so you have negative. So negative times negative, you have positive here. So we're done with the differentiation rule. The next one is, of course, so that given na dapat yung final answer mo. I mean, your final answer should be a second order because of two arbitrary constants. However, meron ka pang nakikitang arbitrary constants dito. So again, you have to eliminate these arbitrary constants. So you can refer to the previous equations that you have. So pwede yung first derivative kung merong similarities, or yung first equation, may similarity dun sa mismong final equation mo. Okay, looking at these equations, you can see that the first equation and the last are equal, diba? So it means our final answer will be y double prime equals y, or transpose y, we have y double prime minus y equals 0. Now let's go to the next example. Now we have two arbitrary constants here. So this means that for you to arrive at its DE, kailangan natin siyang i-differentiate ng dalawang beses. Okay, so for the first derivative of the given equation, so we have y, derivative ng y is y prime, and then equal yan sa first term natin, c sub 1 is a constant or arbitrary constant, so you copy that, and then differentiate e raised to 2x, so you copy e raised to 2x, and then differentiate 2x, which is times 2. Now, for the second term, we have c sub 2 e raised to minus 3x, so you copy c sub 2, and then differentiate e raised to negative 3x, so you copy that, and then differentiate minus 3x, which is negative 3. So you have your first equation. Now, the next part will be to differentiate again. So y double prime, you copy c sub 1 constant, and then differentiate e raised to 2x. And derivative of 2x is 2. So 2 times 2, multiply mo sa coefficient, yan, 4. And then here we have c sub 2, e raised to minus 3x. You differentiate minus 3x, so that's minus 3. Minus 3 times minus 3, you have positive 9. So this will be your second equation, or you can label that as equation number 2. Now, hanggang dun lang yung pag-differentiate mo, hindi na mag-differentiate ka ulit hanggang sa gusto mo lang. Again, reminder to everyone, yung requirement is that kung ilan yung arbitrary constants, hindi kung ilang beses ka lang mag-differentiate. So we are done with the differentiation rule now, or the differentiation step. So we have to do something with these equations. So it depends on what is more convenient to you. So you can eliminate C sub 1 first, solving C sub 2, or you can eliminate C sub 2, solving for C sub 1. So as you can see dun sa final equation natin, you have 4 C sub 1 e raised to 2x and plus 9 C sub 2 e raised to minus 3x. So as you notice here, yung coefficient ni e raised to minus 3x, di ba? Magkaiba yung sign nila. So ano yung gagawin natin para ma-eliminate natin tong part na to? We can introduce, di ba, a factor. You can multiply the entire equation 1 by positive 3 para magpareho sila. You can see, di ba, that there are similar terms, thus solving for C sub 1. Now let's do this. So we solve first for C sub 1 and eliminating C sub 2. Okay, step by step lang. C sub 1 e raised to 2x. So to do that, we will multiply the entire equation 1 by 3. So equation 1 times 3. And after doing that, we add equation 2. So 3 times y prime. Okay, take note, equation 1. So we have 3 y prime equals, and 3 times 2, you have for the first term 6 c sub 1 e raised to 2x. And then 3 times negative 3, you have minus 9 c sub 2 e raised to minus 3x. So this is now the result of multiplying equation 1 by 3. And then you add equation 2, which is y double prime equals 4 c sub 1 e raised to positive 2x plus 9 c sub 2 e raised to minus 3x. So as you notice, there are similar terms. So you can combine them, and so the objective of this is to eliminate one of the constants, arbitrary constants. So 3y prime plus y double prime, just copies, wala namang similar terms dun sa left-hand side. 6 plus 4, so you have 10 c sub 1 e raised to positive 2x. And then minus 9 plus 9, makancel na natin yung part na yan ng ating equation. So, solving for c sub 1 e raised to 2x. So, may coefficient na 10 dyan. So, we divide both sides by 10, giving us c sub 1 e raised to positive 2x equals, copy natin, 3y prime plus y double prime all over 10. So, this is now the value of c sub 1 e raised to 2x. Now, working on the other part, to eliminate c sub 1. So we solve c sub 2. We solve for c sub 2 e raised to minus 3x. So ang ginawa ko dito is kinopya ko muna yung first two equations kasi hindi natin mabalikan na mamaya. So to do that, we will multiply the entire equation 1 by, so ano yung gusto mo? Pwede mo kasing i-subtract yung dalawang equations, di ba? Provided that pareho yung coefficients ni e raised to 2x. So it's either you multiply it by 2 and then subtract equation 2, or you multiply equation 1 by minus 2 and then you add equation 2. Okay, para magkaiba sila ng sign. So here we multiply equation 1 by negative 2 and then we add equation 2 after. Okay, so first, multiply the entire equation 1 by negative 2. So we have minus 2y prime equals minus 4 c sub 1 e raised to 2x. And then minus 2 times minus 3, you have positive 6 c sub 2 e raised to minus 3x. Okay, ito na yung result ng after natin ma-multiply yung equation 1 by minus 2. And then we add equation 2. Y double prime equals, just copy, 4c sub 1 e raised to 2x plus, okay, 9 c sub 2 e raised to minus 3x. Okay, so add lang natin sila, combining like terms here. So minus 2y prime and minus 2y prime plus y double prime equals, so minus 4 plus 4, makancel na natin yung c sub 1. And then 6 plus 9, you have 15 c sub 2 e raised to minus 3x. Okay, so solving for c sub 2 e raised to minus 3x, we divide both sides and by 15. So you have minus 2y prime plus y double prime all over 15. Now we have now c sub 2 e raised to minus 3x. Okay, and then we substitute the value of c sub 1 e raised to 2x and the value of c sub 2 e raised to minus 3x to our given equation. So if you recall, y is equal to yung given natin, c sub 1 e raised to 2x plus c sub 2 e raised to minus 3x. So ganun lang, i-plug in the values of these expressions. So we have y equals, what's the value of c sub 1 e raised to 2x? If you recall, that's 3y prime plus y double prime. Okay, all over 10. And then the value of c sub 2 e raised to minus 3x is, that is minus 2y prime plus y double prime all over 15. So as you can see, wala na ka nang makitang arbitrary constant dyan, di ba? So yan na yung final answer mo. Sana kung na-simplify mo yan. Pero you have to simplify. You must simplify your final answer. I will simplify this one. Now think of the least common multiple and multiply to the entire equation. Para matanggal natin yung denominator natin on 15. So the least common is 30 multiple. So multiply the entire equation by 30. So we have 30y sa left-hand side equals 30 divided by 10. So you have 3 times 3y prime plus y double prime plus, again, 30 divided by 15 is 2 times minus 2y prime plus y double prime. Okay, so we distribute yung 3 and 2 dun sa first and second terms. So 3 times 3 is 9, y prime 3 times y double prime is 3y double prime plus 2 times negative 2 is minus 4y prime. 2 times y double prime is 2y double prime. Then combine mo yung like terms. You have y double prime, y double prime, y prime, and y prime. So copy lang 30y equals 9y prime minus 4y prime is positive 5y prime. 3 plus 2 is 5y double prime. So yan na, na-simplify na natin, but may common pa rin sa kanila. Yung 5, divide both sides by 5. You have 30 divided by 5 is 6y equals, yan na. So y prime plus y double prime. So this is now your final answer, or you can arrange from the highest derivative up to the least. So you have y double prime plus y prime minus 6y, transpose mo lang yung 6y, equal to 0. So as you can see, the final answer does not contain an arbitrary constant. So second order siya because of two arbitrary constants na present to sa equation. Kasi dalawang beses ka nag-differentiate. Now let's move on to the next example. X minus c sub 1 raised to 2 plus the quantity y minus c sub 2 raised to 2 equal to 1. So this example contains two arbitrary constants. It means that you are going to differentiate this twice. Let's differentiate this dalawang beses. Again, take note that y is our unknown function or our dependent variable. Kaya kapag dinifferentiate mo yung unknown function, so makita mo yung prime na notation dyan mamaya. Let's continue. Yan, ito yung sinasabi ko na, di ba yung sa chain rule, differentiate mo to. So this is 2 times y minus c sub 2. Differentiate this part of the term. Derivative ni y minus c sub 2. So this is y prime minus 0. So kaya nag-multiply ka ng y prime dito. Dito naman, yung derivative nitong x minus c sub 1 is just 1 because of the independent variable na x. Okay, and then derivative of 1 here sa right-hand side mo is 0. Okay, so before you proceed to the next differentiation, pwede mo munang i-simplify, or since may common do sa first and second term na 2, you can actually remove that by dividing both sides by 2 or multiply both sides by 1/2 para matanggalan natin yung 2. So x minus c sub 1 plus y minus c sub 2 times y prime equal to 0. Ito na yung ating equation 1. So, tandaan niyo first differentiation pa lang. So, you need to differentiate again. Yan, for the second and final time. So, you have derivative ni x is 1, derivative ni c sub 1 is 0, plus yung second term natin, naka-factor yan, di ba? Yung y minus c sub 2 times y prime. So, you can follow the product rule for differentiation. Ano yung product rule? UdV plus v times du. So here we copy y minus c sub 2 and then differentiate the other factors. So y prime becomes y double prime plus you copy y prime and differentiate mo yung y minus c sub 2 and that is y prime. So y prime times y prime is equal to y prime squared. This is supposedly our final answer. However, there is still an arbitrary constant. So, kailangan nating matanggal yung arbitrary constant. So, i-write ko muna 1 plus y minus c sub 2 times y double prime plus y prime squared. Okay, equals 0. Equation number 2. So, what you will do here is you can solve for kung saan yung mas convenient, guys. So here, ang gagamitin ko is equation number 2. I'll be solving for y minus c sub 2. After nyan, ang gagawin ko is i-substitute ko siya sa equation number 1. So ganun lang, solve for y minus c sub 2. So ayusin ko lang tong equation 2. Express ko siya in terms of y minus c sub 2 equals. So, ganun. So, the rest of the terms on the left-hand side, transpose lang sa kabila. And copying ko muna yung y minus c sub 2 times y double prime. Transpose mo yung 1 and y prime squared to the right-hand side. So, magiging minus 1 minus y prime squared. Now, solving for y minus c sub 2, so kailangan natin matanggal yung y double prime there. That's why we divide both sides by y double prime. Now, we have y minus c sub 2 equals, since common yung negative sa dalawang terms natin, so factor out negative, we have 1 plus y prime squared all over y double prime. Adjust ng konti. So this is now our equation number 3. Yung result natin dito, we will substitute this dun sa equation number 1 para ma-solve natin yung x minus c sub 1. So the idea is, I'm going to plug in the value of x minus c sub 1 and y minus c sub 2 doon sa original or given equation. So x minus c sub 1, just copy that. And then you plug in the value of y minus c sub 2, which is negative, so maglagay ka ng bracket, minus times 1 plus y prime squared. Okay, all over y double prime. And then, nakamultiply siya sa y prime. Ito yun, equal to 0. Now, what we will do is, we will solve for x minus c sub 1. So we transpose this term dun sa right-hand side. So we have x minus c sub 1 equal to, or equals, magiging positive na yan, di ba? So 1 plus y prime squared times y prime all over y double prime. So this is now, this will serve as our equation number 4, yung value ni x minus c sub 1. And then we will substitute again these equations number 3 and 4 dun sa given natin na problem or equation, which is x minus c sub 1 raised to 2 plus the quantity y minus c sub 2 raised to 2 equal to 1. So we have, for x minus c sub 1, you have 1 plus y prime squared times y prime all over y double prime. And, okay, raised to the power of 2. And then you plug in here the value of y minus c sub 2, which is minus 1 times the quantity minus times the quantity 1 plus y prime squared. Okay, all over y double prime. Okay, equal to 1. Or don't forget, ito pala ay naka-raise to 2. Okay, so the next step will be to simplify. We apply now itong exponent na to sa bawat term. So you copy 1 plus y prime squared raised to 2. The same dun sa kanyang factor na y prime. So magiging y prime squared siya. Yan. Ganun din sa denominator mo. So y double prime becomes y double prime squared. And for the second term, so pag in-square mo yung negative na expression, magiging positive yan. So 1 plus y prime squared raised to positive 2 all over y double prime squared equal to 1. Now, the next step will be to remove these denominators. Common naman sa kanila, di ba? So multiply both sides by y double prime squared. Thus we have, so 1 plus y prime squared raised to 2 times y prime squared plus, second term natin, 1 plus y prime squared raised to 2 equal to y double prime squared sa right-hand side ng equation natin. Yan. So malapit na tayo sa final answer natin. As you can see, you have common, di ba, doon sa dalawang terms. We can factor out, di ba? Naka-factoring by grouping na siya na format. So ano yung nakita natin? So common yung 1 plus y prime squared raised to 2. So factor out lang natin. So you have, ang matitira sa unang term will be 1 y prime squared. Ang matitira dito is plus 1. Again, ang factor out natin is 1 plus y prime squared raised to 2. So dapat naka-raised to 2 ito. Okay, tama. Okay, na-gets ba yung process na to, guys? Common yung 1 plus y prime squared, yan, raised to 2, sa dalawang terms. So, ang ginawa natin is we factor out this expression. Okay, so nung nilabas natin ito, ang natira sa unang term is y prime squared. Nung nilabas mo to, ang natira dito is 1. Okay, that's why, napansin niyo pareho lang to, di ba? Magkaiba lang yung nila, arrangement nila. So you can combine actually these factors. So you combine them, 1 plus y prime squared. Yan, law of exponents lang. The exponents will be added. So 2 plus 1 is 3. Equal to the right-hand side, the y double prime raised to 2. So we were able to simplify this differential equation, or you can arrange, and kung napansin niyo, di ba, naka-box na yung resulting equation, or you can actually arrange, di ba, from the highest derivative. So y double prime squared minus 1 plus y prime squared raised to 3 equal to 0. And this is our final answer.